No.
What about now?
Yes, 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 yes.
Okay, cool, cool. So all right, let's start here. So first things first, I'm going to start talking about the idea of first off, how'd you all go in your trials? So I've already asked these two. They were like, ugh. So I mean, were you guys the same? Were you, yeah, generally dying? Okay.
Better than extension 2 than extension 1.
So you felt extension two was better than extension one? Awesome. And what about you?
Yeah.
You were just like die, like death kind of thing. Yeah, cool. Last time I was with you guys, we talked about obviously we talked about extension two here. So this is not you guys. This was you guys back here somewhere. Where are you at? Come on, where are we at? Does Julian have extension two questions on his thing, on his like exam generator thing?
He started it, but I don't finish it.
Oh, okay. So we've got complex numbers, proofs, mechanics, vectors, and integration. And I think we all said that complex numbers was bad. I was asking them for feedback on the last class, and they were saying they wanted more examples. So I just spammed them with examples in the last one. So I think hopefully that was okay. That was okay. That's kind of what you're looking for a bit more. So I'm going to do the same in extension two. So that's going to be pretty straightforward. But also at the same time, the reason I think you guys could see why you were struggling with prims and coms was you didn't get permanent comms, right? Like you just completely didn't understand it. So that's same problem with complex numbers, but we'll do a little bit where I'm gonna show you questions and solve problems at the same time, right? So solve problems, do theory at the same time. But what I'm interested in is not so much. Do you guys still agree with this now that you guys have practiced? Complex numbers are still your weakest subject, would you say? Now that you've practiced, or do you think that proofs has taken the lead, or where are we now? You reckon proofs is worse for you? And then how are you feeling about it? Does this sort of still hold up now that you've practiced for your trials? So George, you missed this. So what I got them to do is rate them from 1 to 10, how much they love the subjects. 10 being the best, I'm fine. So most of them said complex numbers is death, proofs is death, mechanics is pretty good, vectors is kind of death. You guys said vectors was really good in extension 1. Do you find extension 2 vectors hard? Or extension 1 vectors is okay? Ah, there you go. That's interesting. Okay, okay, cool. All right, that's fine. Once we elaborate a bit more on that shit I was telling you guys last time, you'll see it easy, not bad. But what else have we got? You guys all roughly agree with these numbers, or are you sort of kind of changed your mind a little bit now? So you're saying proofs has overtaken complex numbers for you now? The rest of you, do you still feel like complex numbers is worse than proof for you? So you're still worse with complex? And Lauren, still worse with complex? Yeah? George, what do you like? What do you feel?
Like my favorite is probably mechanics.
Why don't you give me your numbers too, so that we're on the same page? GE. So give me numbers up to 10, just so I know.
Complex probably like 5.
5. Yeah. 6.
Proofs like
4.
4. Mechanics like 8 maybe.
Mm-hmm.
Vectors like 6.
Mm-hmm.
Integration like 8.
Okay, cool. So we're not going to spend a huge amount of time on integration then. Okay, so that's going to be fine. But you pretty much reckon you're going to kill this exam, huh?
Which one?
Extension 2, you're just like sick
I'll
cunt?
take that, but
Complete sick cunt, yeah. That's what he's done. Okay.
I'll go over 75.
No. You reckon you got over 75 on the exam?
Hopefully.
Ah, that's good. Nice.
It's not
Nice, George. What are you ranked in extension 2 at the moment?
bad. 4th maybe? 5th?
4th or 5th? Okay, cool. Who's first? Who's first?
Darren?
Darren's not here. So the one cunt that doesn't come here is coming first. What the fuck? That's bad. That's never happened before. That's not good. What was Darren like? Is he an Asian kid or something? No. All right. Well, we have to beat him in HC. That's it. I don't like going down. So we're not. That's not happening. Who's second? You?
I was second, but no.
But you reckon not after that? Okay, cool. All right, well we're gonna fix that. Don't worry. But what we're gonna need to sort of work together a fair bit here. So I'm putting all of extension 1 and extension 2 in the same book here, by the way. Now let's talk about how to prepare for the HC. So here we've had a long-standing tradition that's been going on for very 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 many years. That has Julian told you about the HC challenge? No. Okay, so we're gonna tell you first about the HC challenge, and this is a tradition that goes back to when I was in your position right now after the trials, okay? So there's just a bit of context here. I didn't want to study in Australia. I'm gonna. Sorry for those that already do physics with me. You've already heard the story. But I didn't want to study in Australia. I wanted to study in America. So I took the SATs. So I was in America 2 days before my trial exam because I got into like a student conference up there and it got into a bunch of unis. So I wasn't in Australia and I wasn't even studying for my HC. I didn't really care about it that much, right? So I was studying, but like not really. It wasn't like my first priority. My first priority at the time was the SAT, which I did well at. I got into a bunch of unis there, and then I came back the day before, and then I was looking at the admission packages and all the prices, and I was like, damn, you see those numbers? It's like, oh man, they're crazy, right? Like 6 digits to finish a degree. I was like, maybe I'll try at the HC, right? I want to do well at the HC as well, so I wanted good marks in both. So my highest rank going into the HSC exams was 6th. Okay, so because I didn't really put a huge amount, except for extension 2, I was 4th. So I was 4th in extension 2, 6th everywhere else, which I think is like probably around where you guys are, if not better. I think you're probably in a better spot than me, if anything, right? I came first by a mile in all the HC exams though. Like I think, so for example, in extension 2, I got I think a 96. And the next person after me was like, I think they were like 81 or something like that, right? And so it's been this HC challenge. So this HSC challenge has been pretty predictive. People who get through this challenge and do it well, pretty much have always been the kids with the 99 ATARs every year, right? So they're always, every year the student who does the best at the HC challenge is the student that gets the highest ATAR. And I've very rarely seen an exception to that rule, okay? So HC challenge has been a tradition we've been doing pretty much since I graduated, so I've done it every single year. And yeah, it's like a rite of passage here. It's like it's the discipline challenge, if you like, right? So the way this is going to work is going to be very, very simple. So I'll get this up for you, Christian. I guess you'd be able to see it too, but let me show it to you. So if I was to go to, so I'm going to send this to all of you right now, and I'm going to show you what the HC challenge is all about. So at this stage, I would expect that for the most part, you're not struggling so much with content for most of your subjects. Is that a fair thing to say? Is that most of the time it's just you don't know how to do specific questions, but you feel like you roughly understand most of the content? Maybe extension 2, that's not true. Would you say? Like for some of the content, you're actually pretty struggling. We can fix that for you together. But for the most part, would it be fair to say that most of the time you struggle is because you are not really so good with the exam itself? Like you can't always get all the marks right. So this is the HC challenge. I'm going to send it all to you. Okay, so I have 2 versions of the HC challenge. So it's pretty much boxes from 1 to 100. Pretty straightforward, right? So what you're going to do is you're going to write all of your subjects here. So like for example, for Tyrese, you're going to have extension 1, extension 2. You said physics. Do you do chem, and what else do you do? English here, and then yeah, what else do you? Religion, and that's it. You got 6 subjects, right? Choose a color for each one. Choose a row for each one as well. And then what you're going to do is you're going to color. Let's say that you're going to do the red one as extension 1. You're going to color these bars red as you do the exams. Okay. And the whole idea is you're going to do 99 exams before the HC. Pretty straightforward, right? Very, very simple. You're going to do 99 exams across all of your different subjects. All right? Not 99 each, 99 total. Fair enough? All get the idea? Fair enough? This is, however, a race, of course. It wouldn't be me if I wasn't going to make it into a competition. So let's make it a competition, shall we? So what I also do for all of you is I go to, let's show you this. So now, I have, so exam challenge 2023. I will give you guys a Google Sheet. Create a new form, okay? And you're going to be erasing all my physics students as well. And you're going to, oh, sorry. Oh, no. Go to live form. No, don't tell me I fuck. Oh, cool. So what's your name? All of your names will be here. Fair enough? I have people from last year to show you here, but your names will be there. You'll click them. You might recognize Jade, right? She's your cousin or something, right?
No.
Or she's like a family friend, you said. Yeah, so like obviously, do you guys know any of these people? You know Jade. Do you guys know any of these other people? Probably not. Okay. Because yeah, we didn't have too many Freemans that year. But so put your name in. What exam did you take? I wrote code to find them all. So just click on the exam and just write your mark. Easy enough? Click submit. What that will do is it will drop it into this thing and it will show you exactly when the exam was taken and what mark everyone got. Fair enough? And then what will happen is if you go to student progress, it will show you how many exams everyone has taken. The goal is to get to 100. This year, it was kind of my fault. I started them off really, really late. But it's pretty funny because the people who did the most exams got the highest mark. It's pretty funny. This person got a 97 ATAR, Helen. She is a English as a second language student. She couldn't even speak English when she joined up. Like she's like bloody killed it. She's extension 2. I think she got like 94 or 93 at the end. Extension 2. She just completely obliterated. Obviously, Jade obliterated. I think you all know that. Edward as well obliterated too. So they all completely killed it. Peter was my physics student as well. He got a 97 ATAR. Owen got a 96, 97. So you can kind of see it's like very predictive. The people who did less. Oh, you guys would know Annabelle as well, right? She was at your school, I think. You guys don't know her? Annabelle Turner? Yeah, I think last year or the year before. 2023. I'm not sure. But anyway, this year is kind of my fault that they didn't get to 100 because I didn't give them the thing very early. So I gave it to them right at the end. So I actually did this a month out. I started this challenge a month out from my HC. So this might sound easy to you, but let me sort of make it clear. In order to get 100 papers done a month out from your HC, that means you have to be doing 3 papers a day, right? Now, in order for you to count the paper, there are rules. You have to take the full exam timed, closed book, and then once you're done, I need you to mark and basically update all your information on that exam once you're done. Is that clear? So what I need you to do is if you're keeping study notes or whatever, I need you to update those notes before you can count the exam. Do you follow that? So whether if it's for math, it's going to be like, okay, look back at the proofs of all the things that you got wrong, or look at sample answers or sample questions or whatever. Fair enough? And you are racing. Every week I will be showing you guys this, and you can literally, you see this great student race, and you can literally see how many papers everyone has done over time. So it's pretty funny, right? You can literally see who's ahead at any given week, and every time I see you guys, I'm going to pull this up and be like, who's winning? That cool? So it's a fun little thing. Compete. The more you compete, the better it is going to be for everyone, right? I actually want you to try to beat each other. Do you all see that? I think Anthony at your school, he's a bit of a shit talker as well. He's going to try to beat you guys. I'm just letting you know. So I actually want you to, just put the little Arab kid in his place, please. Like, that'd be good. I do like Anthony. He's a sick cunt. But he's your friend as well, right? You're friends with Anthony. So, yeah, please, if he beats you, I'm literally going to be putting a lot of shit on you guys. I'm just letting you know. And I know he's going to be working really hard. So just saying. Do you all follow that, or anyone have any questions? Pretty straightforward. So who's excited? Who's excited to do this? Does this sound? Is this kind of thing your jam? Like, you guys feel like you're gonna give this a go, or not really? You're gonna give it a go, or you're gonna be like, nah, sack, whatever. I want you guys to actually give it a try, because I promise you, if you do this, and if you're this green person, you're gonna come first. That's gonna be how it is. And if you're this red person, like, you can kind of see that. You can see the little desperation attempts. You see the little desperation exams that show up here. It's like, oh, that sucks. You can kind of see these people over here, like, you screwed it. These people didn't do that well. It makes sense. This graph is directly going to correlate with how well you go. Is that cool? So what you want to do is you want the gradient to be as high as possible. So highest possible would be about 3 exams a day. I think if you do more than 3, that's insane. If you want to blow past 100, be my guest. I'd love that. I've seen that a few times. Those students did very, very well. Okay. I think last one that blew past 100 was Andre Georges. Do you guys remember Andre Georges? He would have been just graduating as you guys were starting, or something like that.
2018.
Something like that. Yeah. He was, yeah, ducks as well. I mean, we've had 8 of the last 10 or something like that. So it's like pretty. The stats are nuts. Honestly, sometimes I say them out loud. I'm like, fucking hell. Okay, so you guys all fine with that? Any problems? So what I want you to do now is, by the end of tomorrow, if you would like to be in this challenge, I need this from you. So there's pretty much one thing you have to do in order to basically be added to that Google Sheet. So let me show you what that is. So I'm going to send you all this JPEG. Fair enough? I'll send you this JPEG. If you want to be included in the challenge, you must show me a photo of the JPEG on your wall. Okay? Simple enough? So I'll just show you this. Where is it? So I have this one here. So my class, my class is called, this is very racist, but it's called Chinaya Only. This was Anthony's idea, you can imagine. But yeah, you can kind of see all of them have sort of posted, the ones that are in so far, have all posted the thing on their wall, right? So I'm going to send you guys the JPEG. I just did that. So it should be, did everyone get it on their messages? So you should have just received it just now. Okay. And start today. Start today. And so the thing will be ready in the next few days, the challenge for you guys, because I'm giving you guys a few days to sort of declare that you're in. Who's in? Who's going to be in here? I'm just curious. Anybody not want to do this? Anyone not want to try? You doing this, George?
Oh yeah, probably.
Yeah, yeah. Probably. That doesn't sound like a yes.
Oh,
Are you in? What are you in? Okay. Lauren, you in? Okay, excellent. So I want you guys to race. Please do. Try to beat each other. The harder you compete, I know this is a very dumb thing to compete over, but the harder you compete, the more, the more likely you are to actually do well at the HC. And the other thing is the winner gets a onesie. So I'm going to buy you guys a onesie. It's going to be a green onesie. It's going to be cute. I'm going to get it from a Chinese store. It's going to be really crap. But it's going to, that onesie, you earned that shit. So, you want to win the onesie. So is it everyone cool? Everyone's on the same page? So that's what I want you to do. That's pretty much all you need to do. Try to win this challenge. Do this, you will definitely get a very high ATAR. I promise you will. Just the only thing is, so you're going to do 99 exams. You're going to do 99 exams. You're going to mark, all of them are going to be timed. All of them are going to be closed book. Closed book, fair enough. All of them are going to be marked. And all of them are going to be noted. So notes taken. Okay, you're going to do 99 exams. You're going to take notes, and then the idea is that right now you're going to just slowly learn all the techniques. By the time you get to the HC, if you've done it right, there should be no nerves on the day before the HC. Every single person I've seen that's ever gotten above a 95 ATAR was calm as hell the day before the HC. So if you feel stressed, do you feel stressed about the HC right now? Do you feel stressed?
Not right now.
Not yet. Can you perceive that you will be stressed? Right? Are you going to be stressed? Do you think you'll be stressed pretty soon? Yeah, stressed. That means you're not ready, right? So that's the idea. So if you do 99 exams, by that point you have seen pretty much every question 10 times. Like the minimum I should expect you to get if you've done 99 exams, if you've done like 10 or 11 past papers for each subject, you're not going to get less than 90 unless you're doing a really shit job taking those exams. Is that fair enough? So if you're doing those exams and you're actually reflecting on them, this is probably the most important step here. Right, so it's always a loop here. You try, you struggle, you improve, and then you try again. Do that 99 times, and the more times you go around the cycle, the higher your mark is going to be. It's very, very simple. Okay. Now every week at the beginning, I will just ask you how many exams you all done. So I'm going to put it up, and I'm going to name and shame you guys. So please don't be that dickhead who's doing the desperation exams, right? So that you just look like an idiot. Don't do it. Is that cool? Any other questions, or are we all clear? All clear? Beautiful. All right, so that's the HC challenge. So that's all done. Please, you got till tomorrow. Send me photos of things on your wall. So go print that shit out, put it on your wall. Okay. So Blake sent me a bunch of questions to try today. So let's try Blake's questions, shall we? So Blake, you sent.
Like 3 questions. One of them was multiple choice.
Okay, that's fine. That's okay. And then after that, we'll generate a bunch of others. So, son of a bitch. So how are you guys? So for those of you that weren't here before, did you guys go well on the trial itself? Like other than maths, were you happy with all the trials?
I think it was decent. Everything except extension 1 math.
What went wrong in extension 1 math?
No, just like unusual questions. I've never seen before.
Oh, okay. That's interesting. So they're just like different to any others you've seen. That's weird.
Did you guys do the CWSA?
Yeah.
Did everyone do the CWSA paper?
Yeah, they're saying they did. Yeah. Did you?
Yeah, that shit was so hard. Why? It was much harder than the extension 2 paper.
Really? Goddamn.
Yeah.
These are the 3 questions. So I'm going to cut that, put that on the next page. All right, let's give this all a go. So there's going to be a bunch of stuff, and then we'll. So again, for each week, I would like you, now that you're taking exams weekly, the expectation is, I want you to really post questions to this chat. So pretty much, don't wait till the day of. Like, post it during the week so that we have shit to work on every week. That's how you're going to get the most bang for your buck in terms of improving as quickly as possible. So what I want you to do is, as you're taking papers, as you take papers, as you go, right? Screenshot with answers, right? Screenshot with answers. And the general criteria that I want you to look for is basically, I got it, or I get it, but there has to be an easier way, right? If you say, I get it, but there has to be an easier way, there probably is, okay? I can solve most of these problems in my head. I can do a lot of the questions in extension 2 just in my head. So I can tell you most of the questions, there is an easier way. Is that fair? So if you see questions where you're like, I get it, but there has to be an easier way, please screenshot it straight away, straight into the chat. Can you all do that for me, right? And also, by the way, when I text the chat, I get a bit lonely if you don't respond. So can you please all respond? That would be nice. Thank you. That would be good. All right. So you can all do that for me, right? Excellent. Sick cunts. Now let's go. So I'm gonna try this one first. Let's try. So unit vector A, B, and C in 3 dimensions are chosen so that A is perpendicular to B, B is perpendicular to C. The angle between theta between A and ABC is as small as possible. What is the value of cos theta? Now, these questions are always pretty much, if you can visualize it, you can solve it pretty damn easily. Can anyone do this in their head? Not trying to show off here, but can anyone do this in their head? No? I bet you the answer is going to be B. I'm just going to prove this to you because I want to show you guys how to do it, right? So how do you think we're going to do this? Was the answer B, Blake? I actually don't. Did you look?
I think it was D, but I don't remember.
Okay.
Maybe, I'm not sure.
It's as small as possible. Cos theta. I think it's B, but let's double check anyway. So let's see. 3 unit vectors A, B, and C. So I'm told that they're unit vectors. Got it? I'm told that they're perpendicular to each other. So A is perpendicular to B. Does anyone know how I got that? Just to sort of see if you guys have comprehended this. Does anyone know how? Actually, before I start, I'm going to ask this of you guys all the time because I think it's a lot better if you guys can sort of answer it. Does anyone feel like they know where to start? Like, what would you do if you saw this in the exam?
Make it a right angle triangle, make it that one.
Yeah, literally, right? So if I was to go ahead and sort of just draw the situation, I've got it like this. You all see that? I've got A, B, and C. Yeah? Now, what I'm going to do is I'm going to draw my little box thing. Yeah? And you'll agree that this vector over here would be A plus B plus C. Yeah? A plus B plus C. Yeah? If that's going to be the case, then what's the length of A plus B plus C going to be? How are you going to find that out? What's the magnitude of this vector going to be? Well, it's tricky because it's like it could be rotated in any random way. You'll agree with that? But that doesn't actually matter because if you solve it for the ijk, if you just solve it for ijk, you'll agree that you could just take ijk and just rotate it into any random angle? So if you solve for ijk, why should the value change if you rotate it? It shouldn't, right? So if I just solved it for I plus j plus k, should equal the magnitude of I plus j plus k. How do I know the magnitude of I plus j plus k? What is it? That's square root of 3. You all see that? Now let's draw a triangle here. So there's this triangle here. You'll see that triangle? And try to draw it. So I've got, on this end, I've got A. And then on this end, I've got, what have I got? A plus B plus C. Right? So this is going to be root 3. I don't really care about that, but I know that this is going to be root 3, which is going to be A plus B plus C. You all see it? And A has a length of 1. Yeah? And if this is theta, what's the cosine of theta going to be? What I said it would be, right? So that's fine. Do you all see that? So that's what I'm saying is a lot of the time you can just visualize these problems, simplify them into simpler problems. A lot of the time you can solve it. Does anyone have any problems about this problem? Or do you feel like you understand the idea? Okay. Now what we're going to ask is who found that problem hard when I put it up? This is much more important. Is like who found this problem hard when I put it up, and let's try to figure out why. Because the whole idea is not to like just solve problems. I want you to figure out why you fucked it up. Okay. So which one of these steps did you not realize? So which one of these steps was difficult for you? Or in other words, I would ask, why were you unable to think about it yourself? So Blake, you asked the question. Which one of these steps confused you?
I just didn't know how to start it.
You didn't know how to start it at all. Okay. So why did you not draw a diagram? Did you try drawing a diagram?
No.
Yeah, no, right. So whenever you're solving a vector problem, the first step is always going to be drawing a diagram, right? So pretty much any time, you're going to start with a diagram. If I had given you the diagram, do you think you would have been able to do the rest of the steps?
Yeah.
Yeah?
Yeah, I think so.
Okay, so then this one's a pretty easy diagnosis. Now for future, anytime you attack a problem, so again, this is a struggle. Every time you make a mistake, I really want you to get very clear on this because this is how you improve quickly, right? So you tried this question. Let's call it tried question 10. You got it wrong. Struggled. Okay. You tried for some time. Why did you struggle? That's mostly important. That's the most important thing. Why did you struggle? No diagram. What's the improvement you're going to make next time? I actually want you to document this every time you fuck up. Does that make sense? So every time you make a mistake, I want you to draw this little picture. Okay? So I tried question 10. I struggled. Why did you struggle? It is. Do not let yourself get away with, I don't know. Don't let yourself get away with that because then you're leaving free marks on the table. Every time you screw up, figure out why you screwed up. Figure it out. If you're not unsure, then try to take your best guess. Look at the proof and be like, which step would I have struggled at, or which step did I struggle in? You're gonna have your own working out right in front of you. That makes sense? So where did you struggle? No diagram, and I want you to make a change to how you approach things in the future. So in this case, the change would be, I'm gonna draw diagrams every time. Draw diagrams always. Fair enough? That might not be a very good, maybe that will lead you to another struggle later. If you choose to always draw a diagram, that might actually throw you off another time, and then you can come up with a better heuristic for yourself over time. But the idea is that that's going to be what we're going to do in general. All right, so let's try this next one. A point A has a position vector 8i minus 6j plus 5k. The line L has a vector equation blah. The point B lies on L and has a position vector blah. Okay. Show that this length is fine. Now, Blake, tell me where you struggle.
I got part I, but then the second part I didn't know if I was meant to use like projection vectors or like what I was meant to.
Cool. All right. Do any of you think you know how to attack this? Shall I give you all like a minute or so to try it, or do you want to? Yeah, you want to have a crack? Everyone have a crack. You get more out of like screwing up. By the way, for future, for every lesson from here on out, right? If a question gets posted, I want you to have the solution that you've tried yourself before coming to class, because that way I don't have to waste time in class asking you to give it a try. That makes sense? Obviously, all the time I spend here just being like, yeah, give it a try yourself, that's kind of wasted time. Is that fair? So from here on, I want you to come to class having done all of the questions that have been posted by Sunday. If a question is not posted by Sunday, I'm not going to look at it in class on Monday. Is that fair? We'll call that. I'll look at it the next week. So all the questions that have been posted from the last Monday till Sunday, I want you to have attempted all of them. If you know how to do it, you don't need to actually put an attempt down. Is that fair? Like if you're like, hey, I know how to do this one, it's fine, I don't even need to write it, then don't attempt it, it's fine. But this one is sufficiently complex enough that we'll need to diagnose it.
What did we say the answer to the last one was?
It's one on root 3.
It was D.
It was which one? D?
Yeah, D.
I beg to differ. A is perpendicular to B. B is perpendicular to C. Hold on. It says the smallest possible value of the cosine. In 3 dimensions are chosen so that, okay, okay, all right, actually, good point. So let's say this, guys. Good point. So we screwed up here. Where did we screw up? We actually did screw up. Blake is right.
Was it because you said that cos theta is the smallest value when the question says that tan theta is the smallest value?
Where does it say that, sorry?
When you just said that cos theta was the smallest angle,
Mm-hmm.
but in the question it just says theta is the smallest angle, which means that cos theta will be the largest value possible.
I'll give you a hint where I screwed up. It's right here. I screwed up here. What did I get wrong here?
B does not need to be perpendicular to C.
Yeah, A doesn't need to be perpendicular to C. So I didn't need it to be. So actually, if you think about it, yeah, these two can lie along a ray. You see that? So these two can sort of lie along a ray like that. Can you all see that disc over there? So if let me sort of try to draw this again. So this could be B. This could be this could be C and A, right? C and A. And that one's going to be B. you all see that? So actually, let's fix it. Let's go ahead and fix this problem. It's good. So again, another problem as well is read the damn question. Is that cool? So number 2, we tried it again, and then what do we struggle with again? So there's no diagram. So I kind of like to do this every time. So I basically had the wrong diagram as well. So the wrong diagram. So what I'm going to do now is I'm going to basically double check the diagram every time. So this is all about exam technique, right? So I'm going to double check the diagram every time. Now that I fucked this up one time, every time I do a question like this, I'm going to do things on the diagram, and I'm going to make sure, I'm going to double check, or I'm going to imagine moving the diagram. This is probably a different way to say this. I'm going to imagine moving points on the diagram, right? And that's kind of the idea. Then try again. So understand that what I mean by moving points, I imagine that we have these 2 points on the disk, yeah, and I imagine sort of moving them around. Fair enough. So what is a plus c? Now a plus c don't necessarily have to be right angle here. So now at this stage they could kind of form a parallelogram. You all see that? So this is a plus c. Let me call this a plus c. Yeah. And then what I'm going to do is a plus c plus b. That's going to go up, kind of like that. You all see it? This is a plus b plus c. You all got that? So what we're trying to do is we're trying to find the cosine of theta. Now the cosine of theta is found between this triangle here. You all get that? So this base is always going to be 1. That's true. But the other base is not. Right? So the other base, what we want to do, if we want to minimize the cosine of theta, so the cosine of theta is going to be, cos theta is what? Let's think about this. So this is actually a harder problem than we first anticipated. So this is very, very band 6. Okay. So how do we do it? So this is a wrong attempt. So let me just kind of do that and just say, okay, this is my wrong attempt. Let's do the right attempt now. Let's fix it. Okay. So let's try to think about how we might attack this. Again, good diagram is like half the battle, always, right? So what are we going to do? Any ideas here? It's a good question, actually. Formidable foe. What do we do? Now the cosine of theta, when you see the cosine of theta, what does that immediately have to trigger your mind to do? Right? I'm trying to minimize the cosine of theta. What does that immediately trigger my mind to do? Use the who? Use the what? Dot product. Yeah? Dot product. Because if you think about it, the length of a plus b plus c times the length of a times the cosine of theta is equal to what? It's going to be equal to a dot a plus b plus c. Everyone agrees with that? Yep. And this is going to be the same thing as a dot a plus a dot b plus a dot c. Yep. You all got that? And now we know that this is 1 and we know that this is 1. All right? So I want the minimum possible value. How do I get the minimum possible value? Right? A dot A I can't control. That's always 1. You all agree with that? Yes? We following? Or is anyone confused about what I'm saying? So a dot A I can't control because it's a dot A remembers the length of A times the length of A, and I know A is a unit vector. So I'm forced to say that the cosine of theta has to be 1 plus A dot B plus A dot C. Yeah? Cool. How do I find the minimum possible value? What am I going to do? A dot B, what's the smallest value I could have for A dot B? What is A dot B? 1. A dot C? Not necessarily 1. You all agree with that? So what's the smallest value I could have? 0. Something's not right. Hold on. A plus B plus C is not, my bad, not necessarily 1. Yeah, so just have to be careful there. So A plus B plus C, let's write this. A plus B plus C cos theta a plus b plus c. You have to be careful there too. So a plus b plus c cos theta. The smallest thing I could have here is going to be 0. Yeah? But now you've got a constraint here. So you're going to go the cosine of theta is going to be 1 plus a dot c all over the length of a plus b plus c. Yeah? And then a dot c is just going to be the length of a times the length of c times the cosine of the angle between a and c. Let's call it theta AC. Is that cool? So how do we find this? What's the smallest possible value I could find? What can I do? I'm trying to minimize that. So how am I going to minimize that? Let's try to think about it as well, just from the picture. This is the a dot c thing. You see that is the hypotenuse here. A dot b dot c. Cosine of theta is just going to be basically this length divided by that length. Do you all agree? So the cosine of theta, another way to look at it is the cosine of theta is going to be the length of a divided by the length of a plus b plus c. Yeah? Cool. So the length of a we know is 1. Yeah? Because length of a is 1. And so what's the minimum possible length of a dot b dot c as I continue to sort of shorten these guys? How do you see it? Now, it just needs a good picture. Again, same thing. This is always going to be the case. It's always going to need a good picture. So why don't I draw for you? Oops. So why don't I draw? Can you? Okay. So you got this a dot b dot c. I want to minimize. You know that's going to be 1. So what I want to think about, I just want to think about what's the shortest possible length I could have for a plus b plus c. Let's think about that. What could I get? How could I minimize that length?
So a plus c will be approaching 2 then?
Why is that?
Because as the angle gets shorter between them, it will be getting closer to like a right angle triangle when using b as well.
Mm-hmm.
Makes sense.
But then if you also think about, like, for example, if I put them like this, right? The length would be root 3, yeah? If I put them right on top of each other, like A and C, like literally right on top of each other, yeah? What would the length here? Yeah, you're right. The length here would be 2, yeah? The length here would be 2, and then the length here is 1. So what's the length on the hypotenuse? Root 5. You all agree with that? So it's going to be root 5. By the way, can I ask you a question? Is 2 root 5 less than 1 on root 3? I just want to double check that. Can you guys double check that it is? Yeah, so then the answer's wrong.
Because theta.
Yeah,
Because theta is going to be smaller though for option B. Cos theta won't be smaller, but theta.
but they're not asking you that. They're asking you what's the value of cos theta.
But it says in the question, and the angle between the two is as small as possible.
Oh, the angle between the two is small as possible. I just completely misread that. Between A and C, okay, my bad. The angle between them is as small as possible. So the angle between A and A plus B plus C is as small as possible. Yeah, that would mean you're going to want to get A plus B plus C as far away as possible. You get that? Because that's going to like make the angle smaller. Sorry, I just completely misunderstood the question there. But then yeah, if that's going to be the case, then it's going to be this one. Yeah. So read the question carefully. Sorry, that's my complete mistake. I just completely misread that. But do you all understand how to answer that if that's going to be the case? Right? So that one's sorry, I just misread the question there. So continuing on, let's do this one. You guys still everyone get part A? Part 1, sorry?
Where did the 2 come from in the numerator?
Which one?
For the last. The answer was.
Because if you think about it, then this length was 2, like we said. Yeah, and this was root 5, right? When we drew it. So yeah, good catch there. Sorry, I just completely misread that. All right, part 1. Has everyone gotten part 1? Anyone not gotten part 1? I'm gonna go around the room here. Sorry, Tyrese, yep. Lauren, yep. No part 1. Chanel, you part 1 now? You think you got it? Blake, you said you got it, and George, you got it. Did you get part 2 as well, George? Anyone got part 2? Okay.
So Ivan, I have a question.
Yeah, tell me.
Is part 2 just the perpendicular distance?
Yes.
Just off reading it.
Yeah. Have you guys learnt the
Okay,
perpendicular
alright.
distance formula? That's not in the syllabus. You're not supposed to know it, but yeah, you can. There are quite a few ways to do part 2, so I'm going to show you a few, right? It's really really an interesting problem, this one. So, and E3. This is not E4 band, but it's an E3 question. It's hard, but not super hard. Because you could just brute force this whole question. It's quite easy to brute force if that's what you want to do. Oop. Sorry. Sorry. Did I show you guys Desmos 3D last week? I did? Didn't? Okay. So when you're learning this stuff, a big thing you want to do a lot of the time is just learn to visualize, yeah? So let me sort of actually, is that enough time for an attempt, or do you guys need a bit more time? Anyone want more time, or can I just start showing you stuff? Start showing? Cool. I want to show you guys how we would have done the first one. Like, let's suppose for a moment, like, okay, I want to really visualize this, yeah? So I want to show you guys techniques so that when you're at home studying, you can do it, right? So this is Desmos 3D. You can just bring it up, just go to Desmos and just type 3D, or just type Desmos 3D. So if you just type in the vector, a plus b plus c, so I think you can type vector in there, and then you just put a point in there, and it will just draw it for you. So if you put in the vector 1, you just choose one. Now a could be the vector a. Let's think about the vector a, what that needs to look like, right? The vector a is a vector, and it could be any vector along the xy plane, right? So if I want a vector that's on the xy plane, it would be cos a sine a 0. Do you all see that? How do you use vector? Requires a start point and an end point. Okay, sure. I can do that for you. 0, 0, 0. Cool. Is everyone cool with that? So this is my vector A. Any problems with that? That's the first vector. I can just put it wherever I want. The second vector is going to be the vector B, right? So that's going to be the vector B. Can I just type A plus B? Yeah, I can. Beautiful. So this is going to be the vector 0 and then cos B sine B. All right? So I want to think about what value, so I can change these two. And the vector C is pretty straightforward. That's just the vector 0, 0, 0 up to 0, 0, 1. Is that cool? So this is the situation I'm dealing with. Everyone can see that? Now I'm going to make the base ones red and then the up one blue, just to keep my life easy. Now you understand that I could sort of set these to be whatever the hell I want. Yeah? So I can also show you the vector A plus B plus C. Cool, that's what that one is. Yeah? And then if I wanted to, I could draw the triangle. So I could actually type polygon from 0, 0, 0 to A plus B plus C to 1, 1, 0. So it's a little bit annoying because I have to actually put these points in. So let me put this point in. Let me call that point A and point B. Are you cool with this? Point A and point B. Oh, sorry. Let me call it U and point B. Is that cool? This is just a bit annoying. I just need to be able to use that point. Can everyone see what I'm doing, or is anyone confused by what I'm doing? Right? So I've got this, and I want to visualize it, right? So it's just a nice quick visual. Sometimes it's like best to just, when you're at home and you're actually practicing this, it's best to sort of visualize it yourself. So then I can just draw a polygon from the point U. So I've got a point. Let's put these points down here so we can see them. So this is point U and V. So I want to draw the polygon from 0, 0, 0 to the point A plus B plus C, which is going to be U plus V, right? I can just even draw it from U because that's the vector A, and then I want to draw it to the top corner. You see that? This is going to be U plus V plus 0, 0, 1, 1, right? Why does it not like that? Does not support the polygon. Oh, sorry. Okay, let's try triangle. Cool. Can you all see that? That's the triangle we're dealing with. And what I'm trying to do is I'm trying to minimize the cosine of theta. So basically I'm trying to minimize you can kind of see that, the size of that angle. And so all I can do is I can change the values of A and B to be whatever the hell I want. You see that? And we want to try it. Now it's told us, the question had told us that the angle between them is as small as possible. So that's what you get. You see that? And then it wants to show, I want to show what the cosine of theta is. So the cosine of theta, as you know, is going to be, it's the length of which vectors? It was the length of A divided by the length of A plus B plus C. It's going to be 0.447, which, let me just drop that down there. Right, so there's going to be 0.447, which is going to be the same thing as the square root of, so 2 on the square root of 5. You'll see that? But that's a different answer. Why is that a different answer? Was it 2 on the square root of 5?
Yeah, because A dot A is 1 and then A dot C is
Oh.
also 1.
Yeah, okay, yeah, sorry, that's right. A dot A, but yeah, we have to include the lengths as well. So sorry, my bad. Yeah, you have to include that. But that is that. I'm just mainly showing you how to visualize it here. I don't really care so much about that. But can everyone sort of see how that works, right? So you want to kind of get a bit used to doing this, especially while you're practicing. So when you get a question wrong, when you're practicing, I want you to come in and actually visualize it in here and actually get used to visualizing it so that you can properly stop screwing it up. Because if you can't visualize it, you're going to get it wrong. As you saw, like when I had the wrong visual, I got the wrong answer. So that's what's going to happen. So okay, let's do that for the second question. So for the second question, it's actually a lot simpler. Using Desmos for the second question is going to be a lot easier. So the second question tells me I have a line. So I've got this function f of let's say xi. So x plus y plus z of ijk. So the point A has a position vector 8 minus 6. So let me just put this in, 8 minus 6 and 5, all right? And the line L has a vector equation x, xi, yj, zk, okay? So as a point, that's gonna start at the point 1, 1, 2, right? So just looking at this equation here, right? So just being very clear here. So this vector, if we want to write it as a parameter, let's just draw it out so we can see what the hell we're talking about here. This is a point A, so let's just draw a point A. Everyone sees that? And then we have a line L. It's going to look like this. Fair enough? Now the line L, you can kind of see has T, I, J, K. So if you kind of want to rewrite this, it's like the X is equal to, you can just see it, it's just T. The Y is equal to just T again. And the Z is equal to 2T. Does everyone agree with that? So this is the point T, T, 2T. Everyone's cool with that? So this point is guaranteed to be on the line. Anyone have any problems with that, or is everyone on the same page there? Right, so I can slide that point around to wherever the hell I want. So let's start there and just visualize what the hell we're talking about before we do anything, right? So what I've got is minus 865, so zoom out, that's that point over there. Everyone can see that? And then I've got a line which should have the equation f of t, which is just going to give me t, t, 2t. Everyone cool with that? So f of, for example, 3 would be over here. Go zoom out here. So that's f of 3, yeah? And then f of 2 would be here. And if I wanted to, I could draft them all. F of 0, f of 1, f of 2, f of 3, f of 4, f of 5, 6. Cool, so it's drawing, that's my line. Can you all see that? And if I wanted to, in Desmos, there's a special variable little t, so I can swap all of this for little t, and it will actually just draw the line from -3 to 3, for example, right? That's my line. So can everyone visualize this situation well? No problem. Can everybody see it, or is anyone confused by what we're looking at here? Right? So it's like a 3D point like this, and you can kind of see, you can look at it from every different angle and try to minimize that. So let's go back here for a moment and try to solve the problem. Show that the length of AB, so what's B? B lines on the point L. Fair enough. So that's going to be B. Everyone sees it? So they've used P's instead of T's. I've used T's. Right? So let's use what they've used and do P's. Is that cool? So just looking back at their little thing, I'm going to make a little slider called P. P equals 3, for example. And then instead of all this crap, I'm just going to write f of P. Everyone cool with that? So you can see that this P, as I change P, is just going to slide along that line. Got it? That's what I'm dealing with. So that's f of T, f of P, right? So that's what we've got here. All right, so looking here, so I might actually just screenshot this for you guys as well, so you can all refer to it when you're practicing yourself. Okay, so I'll just screenshot that for you, and I'll drop it in here so you can refer to. This is what you do to visualize this crap. Should I include the actual visual in the screenshot? Maybe I'll do that for you so you can see it, right? So let me just. Everyone cool with this? Anyone confused by anything I did in Desmos, or is it straightforward? All right, so I'll just include this here. You can look through it. Obviously, you'll have access to the video, so you can just watch what I did. But this is how you would visualize it. So now let's solve it. So AB, how do I find the length of AB? If I want to find the length of AB, I'm just going to take B minus A. Everyone gets that? So b minus a. A is the point. What's the point again? 8 minus 6, 5. Yep. So b minus a is just going to be 8 minus p. So p minus 8. P minus 6, so p plus 6. And 2p minus 5. Everyone cool with that? So then the length of AB squared is just p minus 8 squared plus p plus 6 squared plus 2p minus 5 squared. Everyone on the same page as me there? Everyone got that? So then when you expand and simplify, you should have gotten AB squared is just equal to 6p squared minus 24p. 24p plus 125. Everyone's cool with that? Now part 2. Give me ideas for part 2. I want to see what you guys thought of. What are all the things that people tried? Did everyone get part 2? Yeah, what did you try? So options. Let's think about the options that we have for a moment. Because I can think of at least 3 ways to solve this problem. So I want to show you all of the ways so you can really be very good at this. Right? I want the shortest distance between point A and the line L. Right? So what can I do? What did you do?
The shortest distance is the perpendicular distance.
Okay.
So you have AB, and then you project it onto the line.
Yep.
And then that creates a triangle.
Yep.
And then you use Pythagoras to find that.
Agreed, right? So that's one way. So the first way is to basically find the projection of A onto the line L, right? So project onto the line L the point A. Is that cool? And then what would you do is just find the perpendicular distance. Right? So you find the projection and then you just find basically the distance from the projection, take the projection, subtract away A, and then take the length. Right? That's effectively what you did, right, Tyrese?
Mm-hmm.
Right? Okay. Can anyone see another way?
Differentiate it.
Differentiate it. So differentiate the length of AB squared with respect to P. Yep. Differentiate it and then set it equal to 0. Can anyone see a third way? Hint, it's a parabola. Find the vertex of the parabola. That's the easiest way. Does it make sense? The vertex of a parabola is going to be the smallest value of P. Do you all get that? So part 3 is actually dead simple. So all you need to do, what's the vertex of this parabola? Vertex equals negative B, so 24 over 2A. So 2 times 6, that's 12. Fair enough? So the vertex happens at P equals, what? P equals 2, doesn't it? The vertex happens at P equals 2. How bloody easy is that? So then what's the coordinate of this point over here? 2, 2, 4. Isn't that what you got, Tyrese?
I found a distance.
Sure, that's fine. But then the distance between those two is what?
Root 101.
Well, I actually don't even need to do that because I could just plug P equals 2 into this, couldn't I? AB squared is going to be 6 times 2, which is going to be what? 6 times 2 squared minus 24 times 2 plus 125, and you square root all of that. And that will give you AB. Do you get the same thing? You bloody do. Do you see that? So everyone sees how I did it with the vertex? The other way would be to differentiate, find when the horizontal asymptote is 0. But you understand how to solve this problem? Is anyone confused by what's going on here? So the idea here is that, again, if you graphed it, let's go back to Desmos for a moment, right? If you graphed it as a function of P, what we're trying to do is we're trying to minimize the function. Let's think about this. If I was to take f of P, that's going to be a point, yeah? And if I subtract away the original point, let's say the point, we call the point A, right? So I take f of P and I subtract away A, that's going to give me a point, right? So f of P, sorry, A. So f of P minus A, f of P is a point. F of P gives me that point. Do you see that? Yeah? And then if I take f of P and I subtract away the point A, which is that point at the top, A equals that. If I subtract away A, I've got that point. Do you see that? So that's my point there. And then I want to take its distance. Fair enough. And then I want to slide around P and see what the smallest value I see is. So it seems like I go down to 10 and then it starts going back up again. See? It goes down to 10, starts going back up again in both directions. So I think that the lowest answer I can see is like, what is that, 10.04 or something? Do you see that? 10.0 something? Which is, what did you plug in when you got it?
P.
Huh? For the distance between the 2 points. Hmm?
2.
The distance between the points. The distance is not 2. Distance
Root 101.
root 101, which is equal to, plug into your calculator, it's about 10.07. See, that's what you get. See, and you can see that's right there. See, look what it's doing on the diagram. It gets to the perpendicular point, which is pretty much what you guys expected. You see that? So you really want to start getting your brain to really understand how all these different things are related. So that's why you need to visualize this crap. If you don't, you're not going to get it. Like, it's just not going to make sense. All right? Everyone cool with that so far?
Do you project the point A onto the line or AB?
It says here, what do you mean B?
Like, do you project A and B onto the line or just A onto the line?
Okay, so if I wanted to do it with the projection, how would I do it? Let's think about it. Let's do it with the projection the long way. Okay? So what I'm trying to do here is like I could just take this point here. So I could use the origin as my sort of thing. Let's say I've got the origin here, right, George? So let's say this is my point A, yeah? If I project that onto the line, what would I get? So let's try it. What's the projection? What's the projection onto the line? So the line, projection onto the line, let's call it onto the line of the point A. Yep. What would the formula for that be? Can you help me?
A dot L
A dot L,
on 2L squared.
2L squared. Why 2L squared?
No, just L squared.
Yeah, just L squared. And then times?
L, like this.
Yeah, times the vector in the direction of L. So what's the direction in the vector of L? It's just going to be 1, 1, 2, isn't it? Everyone agrees with that? 1, 1, 2 is going to point in the direction of the line. Yep. If you don't like that, again, go back to your visual. Go back to your visual straight away and really try to make sense of that. Let's draw the vector. Let's draw the vector from the origin. Get my head out of the way. So the vector from the origin, vector. Where's the starting point? The origin. So 0, 0, 0. In the direction of, what do we say? 1, 1, 2. Does that indeed point along the line? Looks like it to me. See? Looks like it to me. Cool. So make sure you know what the hell you're doing. And then if that's going to be the case, then A dot L is what? A is, what did we say A was again? 8, negative 6, 5. Yeah? So therefore, projection of LA. A dot L is what? Help me out.
8 minus 6 plus 10.
8 minus 6 plus 10.
7.
Sounds good to me. And then L squared is 6, I think. And then you're going to multiply that by L, which is 1, 1, 2. Yep. So what do you get when you plug all of this in? 8 minus 6 plus 10 on 6. Isn't that just going to be 2? Which is the same thing as the value of P. Yes? Cool. So it all works. All the methods should give you the same answer, unless you are, screwing it up. I was going to call you a moron. But anyway, do you all get the idea? Any questions? So again, can you all say, so what do we learn here? So again, I want to see, like, what do we screw up here? So what do we learn from doing this one? You got this one wrong, or you didn't get it, right? What do we learn here? So struggled here. I'm always going to sort of do this with you guys just to get you really, really, so you tried question, whatever this was, A, right? So question A, of whatever it was, right? All right. So question A, what did we struggle with here? So we struggled. What did we struggle on? What did you think? What do you think most of you struggled? So what's one thing that you screwed up? Well, first thing, you didn't think to use the discriminant or the vertex, right? So no vertex. Okay. So then what you can start to do is that if parabola, ask if vertex is better. Okay? Because I promise you that you're going to get some problems that are going to be almost impossible to solve if you don't use the vertex method. They're going to be almost impossible to solve. They're going to be so hard. You need these things called like, there's a higher mathematics technique called a Lagrange multiplier. Okay? And if it's a parabola, it simplifies to finding the vertex. But if it's not a parabola, you're going to be there like, what the hell do I do? Is that fair? So in those cases, if you have a parabola, always ask, can I just use the easier method? Right? That's one thing. The other thing is, couldn't see it, right? Couldn't visualize. So use Desmos 3D, right? So I'm trying to like really just make this very clear to you. The more of these things you follow, the less mistakes you're going to be making in a week. I promise you. Is that fair? So now when you're trying to do these things, actually try to Try to do it. A lot of the time, if you don't know what to do in Desmos 3D, by the way, you can just ask ChatGPT. It will tell you what to do. It will just tell you what to type. Like, it'll even give you the formulas to paste into Desmos, right? So it's like, I want to visualize this. Help me. It'll just spit out the formulas and you just paste them in. Is that cool? Is that cool? So for the complex numbers z and w, it is known that the arg is equal to that. Find this. You guys were all saying that the locus questions are kind of problematic for you, right? This one's not really as a locus question, but kind of is, right? So let's try this one. What are we doing? So if we know that the arg of z on w, what does this imply? If we said that arg of z on w is minus pi on 2, what does this kind of tell you? What does this immediately tell you? So again, picture please. We've already made that improvement. So what are we going to do? So let's make a picture. Help me with the picture, guys. What does it look like?
Are they perpendicular to one another?
They are, but specifically, okay, so let's place z somewhere, shall we? Let's place z. All right, so let's call this angle theta. Right? So this is z, and that's the angle theta. Yeah? If I do the arg of z minus w, what does that imply about w? So theta, let's call the angle, let's say arg of z is equal to theta, and let's say the arg of w is equal to, I don't know, let's not use theta, let's use alpha and beta, because nicer, right? So alpha and beta. What does this imply? Arg of z on w, arg of z on w is the same thing as what? Arg of z minus the arg of w, which is alpha minus beta. Do you get that? What is that? If it's a negative number, what does that imply? That means beta is larger. Do you all get that? Beta is ahead of z. That's important, right? So that means beta, that means if that's z, then this must be w. And how far ahead is it? 90 degrees ahead. That makes sense? So this must be w. So if this is alpha, then this is beta. Everyone cool with that? Any problemos? Very good. So what now? Find the length of z minus w on z plus w. This is actually pretty straightforward. Z minus w, what does that look like? A lot of these you can solve just with a picture, by the way, right? So what does z minus w look like? Do you guys know how to visualize z minus w easily? So if I have a vector z and I'm subtracting z minus w. So here's the vector w, yeah? Just two random vectors, yeah? Z minus w, do you agree that that's the same thing as z plus minus w? Yeah? So do you agree that that's going forwards along z and backwards along w? Yep. So that means if I start at the tip of w and I go backwards along w and then forwards along z, so that's minus w plus z, do you agree that that's the same thing as z minus w? This is z minus w. So in other words, this is the final position. Z is the final position and w is the initial position. Do you all get that? So z minus w is end at z, start at w. That's what it means. Do you get that? So z minus w, what does it look like on my picture? Where am I ending?
Z.
Ending at z. So this is z minus w. Beautiful? You happy with that? What does z plus w look like? What does z plus w look like, guys? It's a vector sum, right? Do you guys struggle with this stuff? With the visualizing stuff? Or like, cause I need you guys to really tell me when you're struggling, because I don't want to just assume that you know stuff, right? So do you struggle with the vector addition stuff, or do you all see this? Right, so do you agree that this is z plus w then? So this is z plus w, this is z minus w. What's the angle between them going to be? What's the angle between them going to be? So you want the length of z minus w on z plus w. Yeah? Could we construct z minus w and z plus w in some way? Is there some easy way to do this? So if this complex number z was, let's try to think about it this way, right? What's it? Now, I'm going to tell you there are 50 ways to solve this problem. So I'm going to try to think of a bunch of different ways, just the same way, right? What's the easiest way that you can see? What ways do you think we could attack this? So I'm just giving you a picture now. What ways do you think we could attack this? Let's see if you guys can figure it out. What options do we have? Now, here you're finding lengths, yeah? So if you're trying to find lengths, which form of the complex number is the easiest to do? When you're dealing with lengths, which one is the best one to use? when you're subtracting complex numbers from each other or adding them to each other, how do you express that in terms of like the cis form, for example? Do the cis forms add nicely? So if you have R cis alpha plus so A cis, let's say we had A cis alpha plus B cis beta, and you wanted to add them, do they add nicely? Is there a nice way to add them? No. Don't use that form. Bad idea, right? Don't use cis, don't use exponentials. Exponentials and cis are good for what? What are they good for?
Multiplying and dividing.
Yeah, they're good for multiplying and dividing. So do not use this form if you're adding. Dumb idea, right? So not for multiplying. You see how like we're really picking apart the question trying to see where we'd screwed up. That's more important than actually just answering the question, right? So not for multiply or divide. That's a little heuristic for you, right? Or div. You really, instead what you want to do is you want to really use the form that's best for addition. Which form is best for addition? Which one's the best for addition? Yes.
X plus IY.
X plus IY. Good. Great. Everyone happy with that? So now let's think about this. If Z is going, how can you express W in terms of Z? Let's ask this question. So how is W related to Z?
Rotated by 9 degrees.
Blake, is there a part 1, part B as well on this? Because I think that this might be missing some information.
No, it's all it was.
I think there's something missing because it doesn't say anything about their lengths.
That's what I was confused about.
So because the lengths could just be anything, right? So do you kind of see that when I look at this picture, I'm looking at, if you want to find Z minus W on Z plus W, right? Well, let's see what it would be, right? So Z would be the same thing as, let's say it was X plus IY. Fair enough? W, how's W going to be related to Z? What are you going to need to do?
Times by I.
Times by I, but then the length could change too. So times by R too. So times by R times I. Do you get that? So this is a or let's call it K for scaling, right? K for a scaling factor times I, X plus IY. Do you all agree with that? So then if that's going to be the case, then W must be the same thing as K, I squared is minus 1, so minus Y, plus IX. Everyone is happy with that? That must be the idea. So this is pretty much the best you can do, unfortunately. So then if you're going to find Z minus W, Z minus W on Z plus W, now you can just solve this in the Cartesian form. So what are you going to get? Z is going to be X plus IY, and then plus W, what are you going to get here? It's minus KY plus IXK, all on the sum. So X plus IY plus KY plus IKX. Sorry, minus KY. Oh, I think I screwed up the top one, didn't I? So I have to subtract it, yeah? So plus KY minus KY. We all in agreement there? I'm going to take the magnitude of that. Yeah? Cool. So for 2 marks, you're going to need to simplify this. It should simplify reasonably nicely if you're going to do it completely brute force algebraically, right? So this is one way to do it, is the brute force. Okay, just using pure brute force. Everyone cool with that? One way to do it.
I just put the answer, they don't use any other information, so that's the whole question.
Okay, cool. That's fine. So that's one way to do it. And so the other way would be to do it geometrically, which is going to be nicer. I'm assuming their solution was probably geometric, right? Okay, so but anyway, let's continue with this and let's try to do it the brute force way. Let's say you screwed, you're stuck in an exam. How do we do this? What do we do? What are we going to need to do to simplify this? Any ideas? We're going to need to rationalize it, yes? Everyone agrees? So we're going to need to rationalize this. So it's going to be X plus KY minus, plus I times Y plus Y minus KX. Yeah? All on X minus KY minus or plus I times Y minus K. Did I screw something up there? Y minus, hold on, X minus KY, that's fine, and then iy and then ikx. Sorry, my bad. Yep. And this is plus. Cool. So all of these are multiplied. So then what you'd need to do is you'd need to go x minus ky. Yep. Minus I y plus kx. X minus ky minus I y plus kx. So you can kind of see that this is going to get very, very hairy very fast, right? But if you did simplify it, if you did simplify it all the way down, it should simplify to something reasonably nice. Is that cool? That's one way to do it. It's not the best way to do it though. I'm going to tell you that, okay? The better way to do it would be, so brute force would be if you were to go through it and just do it all the whole way through, you're going to end up with an answer, and it's going to be in terms of the length of z and then in terms of the length of w. Is that cool? So you're going to need to write it in terms of the length of z and the length of w. But obviously this is going to be a lot of algebra, but it will work. Okay, so it will work. So if you're completely screwed in an exam, you can always do this. So when you're doing it under time conditions and you're practicing, it will work, but it's generally not the best idea. So pretty much when I'm doing extension 2, if I see something expand out to that, my immediate thing to do is I'm going to be like, let's look for a different method. This method is not the right method. I promise you, right? So the better way to do it would be using geometric arguments, okay? So let's try this. So what I'm going to do now is I'm going to use the geometric way. So what I'm going to do, new picture, geometry. So let's pick z. So we know z, I can rotate the whole thing so I can make it easy for myself. So I say this is z, and I know that w would be here, and it would be a different length potentially. Z and w do not necessarily have the same length, but w comes after z. Fair enough? So this I know is z plus w. Yep. And then this I know is z minus w. Sorry, z minus w ends at z. Cool? You got that? Now, I'm going to try to express both of these in terms of the angle and the argument between them. Can I do that? So let's suppose that this angle over here was theta. Yeah, say I knew that angle was theta. Or even if I knew, say z plus w looked like that, let's try to express everything in terms of all the angles that we have. So we know that this is a right angle. So what I can go ahead and do is I call that angle alpha, just to sort of work with it. Is that cool? So that angle is going to be alpha. Then do you all agree that that angle is going to be alpha as well? Yep. Everyone cool that? So because it's a it's isosceles there. That's also alpha. That's also alpha. Yep. And this would be 90 minus alpha. This would be 90 minus alpha. What does that make this angle? What does that make that angle? So if you did 180 minus 90 minus alpha, minus 90 minus alpha, these guys go bye-bye, so it's 2 alpha. Can you all see that? Or another way you could have done it if you wanted to is you could have sort of like drawn this in and realized that that was going to be alpha, that was going to be alpha. So this is all 2 alpha. Fair enough? Everyone cool with that? Okay, now let's think about it. If I take this complex number, what am I looking for? I'm looking for z minus w on z plus w. Yes? Z minus w on z plus w. Z minus w on z plus w. Can I express that? Now what is z minus w going to look like? What's that going to look like? Can somebody express it as a, like, for example, in terms of alpha? How do we do that? So z plus w, I can sort of think of it as, if you know that this is the length of w, you know that this is the length of z. Yes? So do you agree that this is the length of w plus the length of z squared? Yep. Do you all agree that this length over here is the length of, so the length of z plus w is what? Squared. Length of z plus w squared is the length of z squared plus the length of w squared, just using Pythagoras. Everyone agrees with that because they're a right angle between each other? Yep. And what's the length of z minus w squared? What do you got? Also the same thing, right? The length of z minus w squared is also going to be the length of z squared plus the length of w squared. So main thing is that length of z minus w is equal to the length of z plus w. This is going to be important, right? We're going to use this. Okay? And then we're going to need to use the angle between them. How do I do that? How do I deal with this? So let's think for a moment. So I'm trying to look for z minus w on z plus w. Yeah? So what's the angle between the two? When I divide them, I'm subtracting the angle between them. Is that cool? So one nice way to do this would be if I was to take this and duplicate it and put it over here. What's the angle between the pair of them going to look like? What's the angle between the pair of them going to look like? What's this angle? How do we figure that out? Do you see what this one is? So this one is z plus w. Oh, sorry. Let me actually draw them tip to tip. Sorry, my bad. So let me draw it from here. So I'm just doing this completely geometrically this time, right? So let me draw. This is z plus w. I'll just draw it from the origin. I'll just pretend that the origin is kind of over here. Can you all see that? So now I've got both of them there. So what can I do? What's the angle between them? How do I find it? Does anyone have any ideas? I don't want to like give you the whole answer. Like, I want you guys to think about it too. What we're doing here? Do you agree that this is kind of finding the angle between the pair of them? The division is going to find the angle between the pair of those two. So really, what I'm looking for is just this angle. Yeah.
If we're finding the magnitude of them, wouldn't that just give us the answer of 1 then? Because you said they're equal and you put them on each other.
Well, the angles are 1. The values are 1, but the angle is not 1. Do you get that?
Because it's just asked, like, it's literally asked for what you just wrote there on the left. Just find the value of that.
Oh yeah, the answer is just 1, isn't it? The length of z. No, it's not. No, it's not. No. So you're saying that the magnitude of, let's say that complex number. Let's say that I've got two complex numbers. Let's call it complex number 1 on number 2. This is not the same thing as the length of complex number 1 on the length of number 2. It's not the same thing. Is it? Is it the same?
Pretty sure.
Yeah? Because if it is, the answer should be 1. Is the answer 1?
Yeah,
So then, that's it. Good point. Because if I know that these two are the same, then I should just be able to divide them. Is the answer 1?
Yeah.
That's it. Then I'm done.
I have no idea how they did it though.
Well, do you see how I did it?
Yeah.
So pretty easy there, right? So as long as I was able to prove that the two of them have the same length, then divide one by the other, I'm done. What's the way they did? Let's look at their answer. You gave me the answer, didn't you?
Yeah.
So let's look at it. I'm telling you that there are going to be lots and lots of different ways to do this. So it says z on w is purely imaginary. Yeah, they use the ki method that I did. So they used the ki method, but they just simplified it a little bit. So the way they expressed it is they said, okay, z. So let me show. They basically said z. They said let z equal ki times w. Does that make sense? That way they didn't have to like do all that expanding, right? So this is the third way to do it, which is even simpler. Again, just having the right insights is going to make everything a lot easier. So then you're going to go z minus w on z plus w, right? That's going to equal. So if you make that substitution, you're going to get kiw minus w on kiw plus w. You see that? And then what's going to happen here? So the w comes out as a common factor, so they cross out. Effectively, the w's are all going to cross out. And you have the ki minus 1 all on ki plus 1. See that? This is a hard question, by the way. So just to be clear, this is a 14C, so it's like near the end of the exam. So it's pretty hard question. So what are we going to do now? Like I said before, rationalize it, right? So it's going to be ki minus 1 multiplied by ki plus 1 on k squared, 1 plus k, or 1 minus k squared, right? Yeah? Everyone's cool with that?
You switched the real part, didn't you? Not the imaginary part?
The real part stays as 1.
Oh, I know, is it?
Yep, because you have to rationalize. And then, so this part at the top is just a difference of two squares, isn't it? So it's going to be k squared I squared, which is going to be minus 1, plus minus 1, isn't it?
Wait, no, wouldn't it be numerator? Wouldn't it be times 1 minus ki?
Oh yeah, you're right. So I'll be careful, yeah. So I'll just do all the algebra. Ki minus 1 on ki plus 1 times ki minus 1 all on ki minus 1. Yes, everyone agrees with that? And then just being a little bit more careful, I'm going to end up with ki minus 1 squared.
1 minus ki times it.
It doesn't matter, right? It doesn't actually matter, no, because again we're just using the difference of two squares to get rid of the bottom.
Right. Okay.
Is that fair? So it's like if you just use the difference of two squares, it's just going to be k squared I squared minus 1 squared, just like that.
If it was any number other than 1, would it matter?
No.
When you flip?
It doesn't matter. Never matters, right? Because you're just using the difference of two squares, and it just squares away the I.
Right,
That's all you're really doing, right? And then you're going to end up with k squared I squared minus 2ki, right? Plus, what's the other one? Plus 1. Have I screwed that up? So we're just expanding this out. See, we're just expanding out that. Isn't that the same thing?
Do you multiply it by 1 minus KI on 1 minus KI?
That's the same thing. That's what I was just telling Blake. So whether it doesn't matter, because like I'm saying, see how you got this and this?
Yeah.
If you did the difference of two squares, it would still make the numerator, it would still make the I squared go away.
Okay.
So the whole thing we're doing is we're using the difference of two squares.
Would the numerator be different then?
No, like, cause okay, you understand that ki minus 1 on ki minus 1 is just 1. So all I'm doing is I'm just saying, okay, I want to get rid of the I in the. So when you're rationalizing, let's think about what we're doing when we're rationalizing. Like if I say 3 plus 4i on 5 minus 7i, right? Let's suppose I write them backwards. 7i minus 5. Cool? You happy with that? I'm trying to get rid of the I in the denominator. So all I'm going to use is I'm going to use the fact that when you do the difference of two squared, a squared minus b squared is a minus b, a plus b, right? So if I knew that I have an I inside this a, then all I need to do is just multiply by the conjugate of that. So I don't actually necessarily need to use the conjugate, I just need to use the difference of two squares. So if I multiply by 7i plus 5, notice what's going to happen, right? So I'm going to get a 3 plus 4i, 7i plus 5. I don't care about this part, that's unimportant. But at the bottom I will get a 7i squared minus 5 squared. Do you all agree with that? And the 7i squared, what happens to that? Turns into minus 1, so it gets rid of that for me. Makes it into a real number. That's the main thing I care about. Do you see what I'm doing there? Do you know that makes sense too? Right? So the whole idea is I've just always been using the difference of two squares. That whole conjugate thing that you were told about. The idea is that I'm just using the difference of two squares to get rid of the I in the denominator. That's kind of been the whole idea the whole time. Right? So that's going to be the case. I can just continue. So let's just be a little bit quick about this. So I'm going to get minus k squared minus 2ki plus 1 all over k. Let's just write that as minus 1 minus k squared. And then if I factorize a minus 1 out of the top, I'm going to get a minus k squared plus 2ki plus 2k minus 1. Did I screw up that expansion? No, the numerator isn't coming out super nice. Minus 1 plus k squared. Is that cool? It's not completely crossing out though. So, is the bottom the same thing as 1 minus k squared? Did I screw something up when I expanded that? Did I screw something up when I wrote this out? Let's see what they've written. They've written ki minus 1 and ki plus 1. That's what I have too. Oh, okay. Okay. Yeah, I'm actually overcomplicating this. Sorry, I'm overcomplicating this again. So I can just rewrite this as ki minus 1. Yep. And I can write this as ki plus 1. Everyone agrees with that? And then I can rewrite this as the square root of 1 squared plus k squared. Right? And then the bottom one is square root of 1 squared plus k squared, which is just 1. Sorry, I didn't need to actually do any simplifying. Got it? The way I did it before was fine as well. I just had to evaluate the length, and you still would have gotten 1. Do you all see that? Or is anyone confused by that? Right? So that's another way. So you have this way, you have this geometric way, and you have this way as well, brute force way. I'm sure there are hundreds more as well, by the way. I'm just giving you, I'm always trying to show you how to solve a problem in multiple ways so you can get exposed to, multiple ways of doing things. I don't want you to think that there's only one way to solve these problems, right? So we weren't really given any more problems. How are we going for time? We have like half an hour, right? So now what I'm going to do here is, you were all saying that you struggled with locus problems last time, right? So I'm going to go to last year's HC paper, HC 2024 extension 2. Have you guys done the locus problem in the extension 2 paper? So let me pull it up very quickly, and let's just look for a locus problem and do it together, shall we? HC extension 2 exam papers. HC 2024 extension 2 PDF. You guys know the trick. File type equals, and then it'll just give you the PDF, but you have to put this in here, should just give you the PDF, but it didn't. Extension to mathematics. Oh, what the hell? Did I spell it wrong? File. I think I'm making a mistake here. I think this might be it. It doesn't seem to. Oh, there, it did work. Cool, but that's Hurlstone. I don't want that. It's just it's show the results of this. It doesn't like it. All right, that's fine. Let's go to the exam papers. I want the exam papers, and then the extension to 2024, and then I'm looking for the PDF. Is this one? That's fine. That didn't work for some reason before, but okay. Let's look for a locus question. Let's look for a question, or anybody who wants to sort of like pick a question that you're like, I want to try it. Let me know. So generally, locus questions are around. Oh, that's the question you just. What's similar to the one you just asked?
Here's the paper I got from all 3 questions.
Oh, okay, sure. Was there any locus question in here?
I'm only
Oh,
I'm
that's
just
that one.
finishing 14.
Okay. I don't want to go all the way to the end because it's like I think we're not there yet. But let's HSC 2024, 2023 extension 2. I can just pull some out of the. Do you want to just pull some out of the textbook? You want to just do that? You guys are. Preview. Let me just pull some out of the textbook then. So full unit is here. Cool. So so you're saying complex number locus questions have been a problem for you guys, right? Are you all generally struggling with those questions? Like when you tried them, have you been getting them wrong most of the time, or do you want to look at something else? What are we thinking? Let's look at some. Fundamental theorem is too high. Chapter 1. Alright, so you've got quadratics, Argand diagram, we've got mod arg form, we've got vectors in the complex plane, and we've got curves and regions. So this is the one that you guys have generally struggled with, right? So let's start here. So when you guys learned about, do you guys understand that there are a few forms that you kind of just want to memorize here, right? So I want you guys to just pick some, and then I'm gonna just work through some with you, okay? So I'm gonna do that. And which of these questions sort of typically looks difficult to you? Are these the kinds of questions you guys were talking about last time? Yeah.
I remember I was struggling finding the equations.
Okay, so pick one and we'll do it together.
9D.
9D, sounds good. So sketch the circles of specified following equations showing their center and the radius. Shall we do that? It's a good question. So let's do it. Now, I'm going to show you all the different methods. There are lots of different methods here, so I'm going to show you all of them. So first thing you can always do, so I want to show you the brute force method in case you're screwed. Okay, so if you're screwed, one is always the brute force method. That always works. Brute force. Okay, now please understand this. I need you to understand that the length of a complex number, is equal to what? The length of a complex number, by definition, is equal to what? What's the definition? This is probably the most important one. What's the length of a complex number equal to? Z times Z conjugate. Okay? You all know this? This is the definition for length. Do not use the square root of x squared plus y squared. That's not the right definition. Don't use that as your definition, right? So let's try this. So sketch the arcs of circles specified by the following equation showing the center and the radius in each case. So again, if you want to find the argument of a complex number, how do we do that? So if you want the argument of z, let's go ahead and plot z on the complex plane. So you've got x plus iy. How do you find its arguments? What do you need to do?
Y on X.
Yeah, it's just going to be y on x, right? So theta, so tan theta is equal to y on x. Yep. But the argument is not the tan of theta, the argument is just theta. Do you all agree with that? So the argument is just theta, so it's actually the tan inverse of y on x. Do you agree? Yep. So you just need to be aware of that. So you need to be able to work with tan, which is a little bit ugly. Tan is quite ugly, but you can always use the brute force method every time. It will work. So let's try the brute force method. So you want a D, right? Let's try the brute force method. I'm going to say let z equal x plus iy. Coolio? Fair? So that's what I'm going to do. And I can also, if I say, so x plus iy plus 1 on x plus iy minus 3, right? The tan inverse of that, or let's say the argument of that, the argument of this is going to equal pi on 3. That's what I know, right? That's what I've been told, and then I want to turn this into a Cartesian equation. The brute force method is just going to be like, okay, just do it. Just, shut up and calculate effectively. Is that fair? You can always use this method. I hate it. I never use it. But I'm just, just in case you need to do it. Let's see how we would do that. So what are we going to do? We're going to rationalize the little dude, right? So we're going to go, okay, x plus 1 plus iy. Oh, guys, by the way, I forgot. Next week, we're going to swap extension 1 and extension 2, if that's okay. Is that possible for everybody? So 4 o'clock for extension 2? Okay? No problems? Good. Okay, cool. Because I just know, like, Blake's got his exam the next day, so he go sleep early. So is everyone cool with that? Okay, cool. So don't forget, next week Blake, you're responsible to tell everybody on the day before that. So on the chat, you're responsible to remind everybody.
Yeah.
Okay? That's okay? If you don't remind people and they show up at the wrong time, I'm going to just run it at the normal time, okay? So just put a reminder for yourself so you don't forget. Alright, so the arguments of all of this, and then you can multiply by x minus 3 minus iy, x minus 3 minus iy. Are you all cool with that? That's going to equal pi on 3. Now, alright, let's simplify this some more. Have you guys all seen this method before? Have you all seen this method I'm following? Or have you not seen it, just like doing a brute force like this? Yeah? So you can always expand out the brackets. You could go x minus 3 at the top, and then you could go plus x plus 1 minus iy. Plus iy, x plus x minus 3, then minus y squared, which is plus y squared. Okay, and then you continue, so you're going to get x minus 3 all squared, yeah, plus iy, so plus I squared minus I squared, which is going to be plus y squared, equals pi on 3. All right. What can we do now that it's been rationalized? We can simplify it a little bit more. So the argument is the tan inverse. So I'm going to rewrite this as the tan inverse of this stuff. Now the cool thing about the tan inverse is that the bottoms are going to cross out with each other, so you don't really need to worry about the bottoms. You also kind of see that? That's why it's cool. So it's y. It's the complex part divided by the real part, right? So the complex part is going to be y x plus 1. Minus y x plus 1. So I might as well write it the other way. And we'll write it as y x minus 3 plus y x plus 1. Do you all see that? And then we can divide that all by the real part, which is going to be x plus 1, x minus 3 plus y squared. Yeah? That's going to equal pi on 3. Now you can take the tan of both sides if you wanted to, so that you get that tan out of there. So what are you going to get? What's the tan of pi on 3? Yeah, it's okay. I don't stop my head either. Use 1 on root 3.
Oh, that's 10. Yeah, root 3.
Just get root 3. So y, I'm going to start expanding now. Do you all see what I'm doing here? So xy minus 3y plus xy plus y, all on x squared. So you got plus x minus 3x, so minus 2x. And you got minus 3 plus y squared equals root 3, you said, right? So that's what you're going to get on that side. Disgusting, but it still works, right? So it's all good. And so you got 3y minus y, that's going to be minus 2y on the top. I'm just going to simplify it a little bit. And this xy plus xy, that's 2xy at the top. Okay, so it's looking a little bit better. Cool. And then here you have a circle, effectively. Can you all see that now we're getting to the circle? We're getting a circle there. So if you move these to the other side, you've got 2xy minus 2y equals root 3 x squared minus 2x minus 3 plus y squared. So if you guys are doing this all yourself, like please make sure I'm not making algebra mistakes. I don't often want to do algebra, so I often make algebra mistakes because I don't use it that often. I often just solve the problems directly, okay? So have I made an algebra mistake? probably. I'm not liking the fact that I have an xy there. I would have wanted that to disappear. So, did you guys have your xy disappear?
I think it's supposed to be minus y outside of x plus 1.
Minus y outside of x plus y?
X plus 1. So from the
You're saying here?
third last line.
Yeah. So what am I supposed to do?
Instead of the plus in the numerator, a minus.
Ah, that'll do it. Makes a lot more sense, because then this will go away. And then you got minus 3, minus 1, so minus 4y. Yeah? We cool with that? That looks a lot better to me. I don't like having an xy because I know an xy is a cross term. So when you mix x and y, you're going to get like weird warped things that are rotated, right? So, by the way, these are all things that you should learn to debug for yourself, right? You want to learn all this stuff, so I shouldn't just say stuff like that. I should show it to you, right? So let me show it to you, what I'm talking about. So if you're doing, so what I mean by it's a cross term, let me show you that. So anytime you have a, I'll show you also like little debugging tactics as well, because it's also good when you screw up to see where you screwed up. So let's show you that. So again, back to Desmos for a second. I just want to show you this. Now, you can also switch on complex mode just by clicking on this and then turning on complex mode. So you can see that there's a little toggle for complex mode on the right. You can literally just switch that on. Okay? So you always just do that. And so then what you can also do is you can just literally type the answer out. Arg of x plus iy plus 1 all over x plus iy minus 3 should equal pi on 3. Okay? So it doesn't like it for some reason. So the arg function is only available in, I turned on complex mode. Oh, it turns itself off. No problem. Okay? That's the answer. So that's pretty good. Then if we haven't screwed up, it shouldn't change as we've been doing our algebra. Make sense? So if I type in minus, when I had like a 2xy minus 2y equals square root of 3 times x squared minus 2x minus 3 plus y squared, like that's what I mean. Whenever you get this xy term, it's always going to be a rotated version of the same thing. So this is something for you to know, right? So if I screw that off, then it's going to look a little bit more like that. But it's meant to be minus 4y. That looks pretty good to me. So we got the same thing, but we just need to, be careful with the angle, right? So you all follow that? So using the brute force method, if you continued going, you'd eventually get there. But I'm going to stop now because this is disgusting. Let's show you a better way to do it, okay? So if you were completely stuck, you could do this and you'd get most of the marks. You'd at least get the center point, and that's okay, kind of, right? So that's not bad. But let's do it a better way. Let's think for a moment. Part 2. All right, now this is where you need to really think properly about the geometry of the situation. Geometry of the situation. Let's think, what does z plus 1 and what does z minus 3 do, and what does the arg of those two things do? So let's do this for a second. So I'm going to draw 1 and 3, right? So I'm going to draw the point. So z plus 1 is the same thing as z minus minus 1. You'll see why I'm writing it that way, but I always want to write it as a minus. So first I'm going to stick on a minus 1. So this is the complex number minus 1. You'll agree with that? Fair enough. And then I'm going to draw on the complex number minus 3. Yep. No, plus 3. And then I'm going to pick some random point z. I don't care where that point is, but I'm going to pick some random point z. Okay. So let's pick some random point z that's going to be over here. Z. Everyone cool with that? Now, let's try to visualize what the hell's going on. Z plus 1 is the same thing as z minus minus 1. So remember, final minus initial. Final minus initial. Always want to remember that. So this over here is z plus 1. Do you all agree with that? Okay, and then z minus 3, that's final minus initial, that's z minus 3. That's what that looks like. Everyone got it? So now what I'm trying to do is that the arg of, if you divide them by each other, what is that the same thing as? When you divide two complex numbers by each other, what are you doing? You're finding the angle between them, aren't you? Do you all get that? So you're finding the angle between the two. So this over here, if you think of this angle is, let's call it, if arg of z plus 1, do you all agree that this is the same thing, arg of z plus 1 minus the arg of z minus 3? Everyone agrees with that? And let's say the arg of z plus 1, let's call that alpha, and let's call this one beta. Arg of z plus 1, let's call that alpha, so that means that is alpha. Yep, and then you're going to subtract away beta. Let's pretend that is beta. You all see that? So then the angle between them is alpha minus beta, that's going to be this angle over here. This is the answer I'm looking for. Do you get that? That angle is always equal to pi on 3. Do you all get that? Yep. Now, this is, then you have to ask the question, okay, so the angle between them needs to be pi on 3. Got it? Now, also the direction matters as well. So it's alpha minus beta is pi on 3, right? So you're effectively saying, okay, alpha here, the only way that it could be, so when you go alpha and you spin clockwise, so notice that this is alpha. If you spin clockwise, you get the pi on 3. Does that make some sense? So this is, if z plus 1 is going to be this one over here, this angle is alpha. Yeah? Beta is a larger angle. So let's say if this is 30 degrees and this is 60 degrees, if you did 30 minus 60, what would that give you? That'd give you a negative answer, wouldn't it? So what I immediately know is I know that the answer can't be on the top half of the plane. It has to be on the bottom half of the plane. Do you all kind of see that? So I'm immediately from that, I know that it needs to be on the bottom half of the plane. Can you all see that? So I need to just ignore the top half of the plane, because if that was the case, if I did the bottom half of the plane, let's think about this. Let's say this is minus 30, and this is like minus 60. So alpha is minus 30. Minus 60 is plus 60. What does that give me? It gives me a positive number. Do you all see that? So I know that it can only be in the bottom half of the plane for that reason. Cool with that? Now we have to just ask, what's the shape? What does the shape look like? Okay, so the argument, the angle between them is pi on 3. Now this is where you just have to know your geometry a little bit to do this, right? So it's actually a property of circles, and this is something you kind of need to know if you're going to solve these problems, right? Is if you take an arc on a circle, it's not super hard to solve this or prove this, but if you take an arc on a circle, you pick anywhere. Let's say that I measure that angle, right? Let's go ahead and measure that angle over there. See that angle, whatever the hell that angle is? Yeah? If I pick any other place on the circle, that angle will stay the same. That's one of the properties that defines a circle. Okay, so if I was to sort of pick this point, you can kind of see it just visually, right? That angle and that other angle are kind of the same. Can you all see it? So, I mean, you kind of see that angle and that angle, they're exactly the same as each other. And that's one of the properties of a circle. So what I'm telling you is that the angle between these two, that needs to be pi on 3, so that means that is also pi on 3. So that means immediately you know you're dealing with a circle. Do you kind of see that? And the circle also has to go through these points. Has to go through both of these points. So this ends up being, well, what is this going to end up being? It's going to need to end up being a circle, right? So this is going to be pi on 3. This angle, I've told you this angle is pi on 3. Do you all get that? That angle is kind of forced to be pi on 3. I can't really have anything else. So then we need to look at the geometry of the situation. So this is going to be pi on 3. And these two are 1 and 1, and I know it's going to be on the other side. So then what I'm going to need to do is I'm going to need to find the diameter, or the where the center point is. The center point, first off, the center point is definitely going to be in the middle of the two, right? It's going to have to be somewhere along the bisecting line. Do you get that? So it's going to have to be somewhere on the line x equals 1. Do you all see it? Just geometrically. So then all I need to do is find the y value of where that center point is, and then I'm done. Can you all see that? So I just need to find the center point. I know it's going to go through, some point over here, and I'm just going to need to find that center line. What's the radius of the thing going to have to be? What's the radius going to have to be? Well, it's going to be a bit hard because you can kind of see that it's going to look a little bit like that. Yes. So just looking at the circle, we want to find that diameter point. We want to find the middle point over there. So I know that if that's going to be pi on 3, I'm going to need to find out what that diameter point is. So one thing I could do is I could sort of do this to the diameter. Yeah, so I could do that. That's one possibility. Or is there? I'm just trying to see if there's like an easy way to do this. There's got to be a very, very easy way to do this. Because for the diameter, the angle has to be 90 degrees. Fair enough. So if this angle is going to be sort of pi on 3, one of the things that, do you guys know this one at least? You know that the diameter of a circle makes a 90-degree angle? You guys remember this one? So we're going to need to use that somehow to solve this problem. So that's pi on 3. How can we use that to get 90 degrees? What could we do there? Because the only difficulty, because you can kind of see here, it's going to look like, it has to look like this somehow. You'll understand that it's going to have to look like this somehow now, right? So we've already proven that. Or in other words, it has to sort of go through here. Okie dokie. And you know that this chord over here is 2. The length of this chord is 2. And that is pi on 3. So here it's just become a geometry problem. I just need to find out where the center point is going to be. So how do I do that? So one easy way to do it is to, let's think about it like this. What if I was to construct this so that it was directly on the center point? Yeah? So if I construct it so it's directly on the center point, do you agree that that's going to be 1? So this length over here is going to be, what is that going to be? It's 2, isn't it? That length is 2. And then the height from here to here is, I'm not sure, but I know that that angle is pi on 3, don't I? Oh, sorry, pi on 6. So half of pi on 3. Yeah? So that's going to be pi on 6. So then I can find that height, couldn't I? How am I going to do that?
10.
Yep, so do 10 of theta, or 10 of pi on 6 equals, what is it? 2 on whatever x happens to be. But obviously just using our special triangles, this is just going to be 2 root 3, isn't it? This height from here to here is going to be 2 root 3. Because you got the 1 root 3 triangle. Yeah? 1, 2, you know the 1, 2 root 3 triangle? 1 root 3, 2. If you know this length is 2, that's double what 1 would be, so that's going to be double what root 3 is going to be. So this is just going to be 2 root 3. Everyone's cool with that? Okay, how do I use that? So 2 root 3 is that whole height. How do I then figure this out? So going from here, if this was the center point, what could I do there? So let's, constructing in the diameter, that's 2 root 3. I feel like I'm missing one piece of information here. I'm kind of missing one piece of information. I don't remember how to get that last bit of information.
I remember.
Yeah.
I'm pretty sure what they used to do is, like, you see how that this angle is pi on 3 here.
Mm-hmm.
Like, the angle from the center.
Mm-hmm.
is
It's
2 pi on
double.
3.
Yeah, it's double. It's supposed to be 2 pi on 3. That's right.
And then you use that.
Oh yeah, that's right. Sorry, I'm an idiot. Yeah, I forgot that. So you just got to know your circle geometry rules to do this. That's basically the point here. So this is going to be 2 pi on 3. Yes, that's right. 2 pi on 3. And then you could have done exactly what we just did. So it would have been 2 pi on 6 there. So pulling out that little triangle. So let's pull out that little triangle. Cool. Sorry, thanks for pointing that out, man. So that's 2 there. This is going to be 2 pi on 3. And then using 10 again, you're gonna solve for that. So whatever that is. So 10, 2 pi on 3 equals 2 on x. Okay? And then if you solve for that, x is going to be 2 on 10 pi on 3. 2 pi on 3. Right? Oops. Is everyone cool with that? So you just plug that in and that's going to be the height there.
Wouldn't that be, you're using pi on 3 then, not 2 pi on 3?
Oh, sorry, yeah, pi on 3. It's literally pi on 3. So what's 10 pi on 3? What's 10 pi on 3? It's
Root 3.
just root 3, isn't it? So 2 on root 3. So x is just 2 on root 3. So therefore, what's the center point? The center point is going to be 1 negative root 3. Cool? And then if I wanted the radius, I'll just do Pythag on this guy. So the radius here would be sine pi on 3. This is pi on 3. Yep, sine pi on 3 is going to be 2 on r. So r equals, what's sine pi on 3 going to be? Root 3 on 2, I believe. So the radius equals 4 on root 3, I think. Makes sense? So then going back to my calculator, let's have a look at that. Does that work? So it's going to be, the center point should be at the point 1 negative root 3. Yep. That don't look right.
How do you know that the x value is 1 for the center?
Wait, sorry. I don't know why I even put in root 3. Sorry, my bad. It's 2 on 10 pi on 3 is what we said, right? 10 pi on 3. And then with a negative sign. That looks better. Cool? So 10 pi on 3 is root 3, so it's negative 2 on root 3. Is that problematic for you, George? Or you
I don't know how you, like, the x value for the center is 1.
Well, it's going to be in the middle of the two endpoints that I found, isn't it? Like, so if you just going back here, so this point is at 3 and this point is at -1, yeah? So it's going to be obviously the middle of those two. Because the circle...
Yeah, I was getting confused because they're not like points on the diameter, but you can just do it.
Yeah, you could do it anyway, because the circle is symmetrical about a center point. Yeah, so you have to really use quite a lot of geometry to solve this problem if you're going to do it geometrically. But if you're not going to do it geometrically, then you kind of just have to go with brute force. That's the best you got. Is that cool? And then so you could have still used the geometry to at least eliminate the bottom. So we got the answer there. right? But the alternative way is to just say, okay, then the answer should be x minus 1 squared plus y minus, what do we say? 2 on root 3, so y plus 2 on square root of 3 squared equals the radius squared, which we said was equal to 4 on square root of 3 squared. Cool? And then you also want all the points where y is less than 0. That's it. Cool? So that's gonna be the locus right there. So if you wanted to write it out in full. Okay? So let's try again. Let's try another one so we can see it. So let's give you a go very quickly. Can you guys try maybe E? Try E yourself. It's gonna be pretty much the same arguments every time. If you want a real challenge, try B. B is actually the hardest one. If you want a proper challenge, try B. So try to sort of follow what I did there and give it a crack. And I will probably let you go after this. So you do have to use the two theorems you kind of need to know are, like, just to remind you, you need to know that one, and you need to know the angle from the diameter. Basically, the angle from the diameter is always going to be doubled. Okay, so basically, if I went through the diameter, the angle from the diameter is going to be twice whatever you picked there from the middle. Oh, sorry, not like that. So the angle to the center, yeah, is going to be double that. So 2 pi on 3. Okay. Well, these are pretty easy to prove just using the symmetry again, right? So it's pretty easy to prove these just using the symmetry of the circle. So we can take a look at that in a second, but yeah. All right. What do we? All right. So let's go through it together. So I'm gonna do B because, like, it's uglier. So let's do B. So drawing it out, I'm gonna write it always as Z minus 1 minus I, or on Z minus 1 plus I. So 1 minus I is 1 minus I is down here. So it's 1 minus I. And 1 plus I is over here. So 1 plus I is here. So I want the argument between them to be equal to pi on 2. So it's actually, sorry, I lied. This one's actually quite easy, to be honest, because the angle between them is a 90-degree angle. So this just means that it's a diameter, right? So this is actually diameter, and therefore it goes straight through the center. So that's pretty easy, right? But then let's choose, is it the positive side or the negative side? Let's see if we can figure that out, because it's also, also good. So let's say this is let's call the arg of Z minus I. So let's pick this here. Z is the final, this is the initial. So the arg of Z minus I, Z of 1 plus I, let's call this argument alpha. Yep, and again, arguments are always measured from here, so it's going to be positive. And then for this position, the angle would be negative, right, beta. So is this the right region? So let's pick an angle here. Let's pick this one and say that the angle of alpha is like 40 and the angle of beta is like negative 30. You all see that? So does that work? So the top angle is alpha, right? So alpha is going to be 40 minus minus 30. Does that give you a positive answer? Right, so I'm going to take the right half of the circle. Cool? It's going to look like that. Everyone got that? So pretty damn straightforward. Let's double check it here. So just in Desmos, again, get used to what to type in here. So you can just put it in complex mode and you just type it straight in. So arg of z, let's go z. For z, you're always going to type x plus iy minus 1 minus I, x plus iy minus 1 plus I equals pi on 2. Looks good to me, right? The center should just be at the point 1, 0, and the radius is just 1. So it'll be, the equation would just be x minus 1 squared plus y squared equals 1, where x is greater than 1. Cool? 30 and 45. Oh, I just made those numbers up. I'm just like sort of saying, okay, let's suppose that this top angle is alpha. Let's call it alpha, and let's call the bottom angle beta. Alpha minus beta. It's for me to sort of check which side it's on, right? I need to understand that this angle, I need to mark alpha properly. So do you see that that's alpha? It looks like a positive answer to me. So let's just pretend the answer was like 40. Well, let's pretend the answer is 10. Who cares, right? And then this one looks like a negative angle to me, so let's pretend it's minus 20, right? So we're doing alpha minus beta, so that's going to be 10 minus minus 20. Do you get that? Yeah. Whereas let's pretend for a moment that I put it on this side. I'll just show you this, Chanel, so you can get it, right? So let's pretend I chose this to be z. Again, it's going to be final minus initial. It's going to look like this, right? So the angle here would be always measured from here. This would be beta. Can you see that? And that would be alpha. In that case, right? So alpha would be an acute angle. So let's say in this case, an obtuse angle. So let's say this was 130, and then this one would be a revolution. So what's this one going to be? This one's going to be, beta is going to be something bigger than 180. So let's do 200. Is that cool? So it's going to be 130 minus 200. Do you sort of see what I'm saying? I'm just making up numbers. That's obviously a negative number, so it's not equal to a positive answer, which is what we want. We want a positive answer, so we know we're going to have to choose the other side. Cool? Makes sense? So that's pretty straightforward. So you're always going to choose one side or the other, and usually the easiest way to do it is just put numbers in and just kind of see. Do you all get the idea? Okay, so these are the kind of the most annoying problems. We'll do a few more of them next week, but again, what I'd really like you to do over the course of the week is, again, there's no point sort of going through them all again. We could do, we can sort of do all of these, but these are generally the most difficult ones. Yeah, I think these ones are the most difficult ones. The rest of them, when you see like a really weird one that you haven't seen before, brute force is the way, right? So if you just like, I don't know the geometry, I'm just kind of screwed, brute force is the way. Just go for the brute force approach, it's fine, right? But then if you see something like, see like this one over here is, okay, describe this, you get some weird stuff. This one is particularly, this one's kind of ugly. I haven't seen this one before. Show that the graph is a circle, kind of like that. It might be a little bit harder to do, so if you're kind of screwed, always just plug in values and try. See, they'll tell you here, by letting z equals x plus iy, and 2 by using geometry. So, sometimes this is like an extension question. This would be like if you see it right at the end of the paper, you'd probably see something like this. Is this cool? But again, as you practice them, again, as you see problems, bring